We are going to do Wilcoxon Cyborg test. What is Wilcoxon Cyborg test? Of course, it was formed or found by Wilcoxon. Signs are involved, ranks are involved. It is a test for location. And that location parameter is theta. And it is used to test scenarios where we have hard data. In other words, we have X, Y that occur in pairs. A common type would be a pre-post experiment. So, for instance, you may want to test the effectiveness of a drug. So you measure the underlying condition prior to the use of the drug, and you give the drug, you treat the person with the drug, and then you determine the effect post-use. Yes?
The location parameter. What is that in parentheses?
Theta. So a pre-post case is an example of hard data because I can't measure, for example, some sort of an illness in one person, give the drug, and collect data from another person. That doesn't make any sense. That's actually moronic. So hard data, a good example would be a pre-post type experiment. A large sample analog to this is the t-test for differences. We're not doing a two-sample t-test where you compare the mean of one to the mean of another population. Rather, it is a t-test for differences. We measure the pre and post difference. Good. Yes. Now, most parametric, non-parametric tests deal with ordered statistics. What is an ordered statistic? Do we know what an ordered statistic is? What is the difference between a regular statistic and an ordered statistic? Mean is an unordered statistic, median is an ordered statistic. What is the difference? Is the data sequential? Or getting closer to that, Paul. Sequential is not the word we would use. But what do you mean by sequential?
It increases.
In order. It is in order, which is why we call it an ordered statistic. So you have to put the data in order prior to computing the statistic. So most non-parametric tests deal with ordered statistics. So what is a Wilcoxon Cyborg test? Well, it wants to test the location parameter, which is the center, to be equal to 0. In other words, the null is the location parameter is 0 against the alternative that the location parameter is greater than 0. The first case would be a typical right tail test. Second case, typical left tail test. The third is a two-tail test. Now, what does the location parameter measure? By all means, the location parameter is going to determine if the differences are meaningful. So going back to our pre-post experiment, if I want to determine the effectiveness of a drug, for instance, diabetes, blood sugar prior to the experiment, high blood sugar, diabetes. Post, in other words, you administer a drug, you measure perhaps 2 months later, 3 months later. What do we expect to have? Should the sugar be low than where we started if the drug is effective, or should it be high? It has to be lower than where we started. That would indicate that the drug is working. Yes? Forget about getting to an optimal level, as if no, we're just trying to decrease it. So, what do we expect the location to be? Should it shift to the right or should it shift to the left? If I did post minus pre, it has to shift to the left, right? Because the post value is going to be smaller than the pre value. Likewise, if you took a different experiment where you want to look at the engine performance because of a fuel injector, and you observe pre-performance and you observe post, and what do we expect in that case when I have the difference as post minus pre? I'm measuring performance. So do I want it to move farther to the right or to the left? So pre, it gave me a mileage of, say, 20 miles per gallon. And the claim is you put this new fuel injector, you're going to get 30 miles per gallon. If the fuel injector is effective, this difference, should it be positive, it has to be positive. The farther the location parameter goes away from zero, the better you have evidence towards supporting the use of the fuel injector. And there are cases where we want to simply say, well, is it equal to zero or is it not? Well, if it is not, then by default, we can determine, is it less, is it greater? So a two-tail test is just a combination of those two. Yes? Okay, so suppose we have a sample of size n. So n observations. So I have x1, x2, ... xn, y1, y2, ... yn. They are paired observations, they occur in pairs. And now I want to find the difference. Mind you, the choice of test will depend on how you define the difference. You can either do x1 minus y1, or you can do y1 minus x1, entirely up to you. But you've got to use a little bit of critical thinking to determine as to what test you should do to address or find evidence to the case. So in a pre-post case, I typically maintain one standard, post minus pre, right? But you've got to be careful in terms of hypothesizing things properly. Now I'm going to come up with Zi, for I equals 1 to n. Going to define Zi to be yi minus xi. That is the difference between yi and xi. Some of them would have positive values, some negative values. Yes. I believe your book uses psi I. Psi I is the sign of Zi. So whether it's a positive sign or a negative sign, but I can't simply use positive, negative. Rather, I can quantify it as an indicator. It is 0 if Zi is less than 0, negative. It is 1 if Zi is greater than 0. What is missing? What should we do if it is exactly equal to 0? Should we call it 1? Should we call it 0? Which makes sense. Huh? Go on, Claire.
I don't think it's either.
You don't think it's either?
Why does it have to be one or the other?
Why does it have to be, or does it? Well, there is a chance you collect an observation, the pre and the post might be one and the same, right? Even if the drug is working for 10 different people, the 11th person must just be an unlucky person and the sugar stays the same, right? In that case, you will get 0. So how do we account for that? Two possibilities. In a situation like that, you can either remove observation where Zi is equal to 0. Oh, yes. Or use 0 and keep all observations. Yes, it is better to use 0 than 1 because when you introduce 1 according to the test, you are introducing effect. In practice, most people would prefer that. Remove the observation where things are equal because we are trying to determine the effect of the drug or whatever underlying treatment that we have. So it's sort of as a moot point to have that. So we will just remove that observation. So first, we have part data. We have Zi, which is the difference between the two. Psi I is the sign of Zi. And lastly, we want to have Ri, which is the rank of the absolute value of Zi. Yes.
Where did that little word, the option right there, the 0, where did that?
I'm telling you that if the sign of Zi is negative, then you make Psi I 0. If the sign of Zi is positive, you make Psi I 1. So we want to assign a rank of absolute value of Zi. Now, if you don't put the absolute value, you're not going to get the correct answer because magnitude is important. We're looking at the magnitude, not the direction. So we have to put the absolute value of the differences, then we get the ranks. Once we have those, we come up with the test statistic. The test statistic is simply the sum of all the ranks. I believe the textbook would use T plus for the sum of all the ranks with positive signs. T minus the sum of all the ranks with negative signs. Of course, yes, it would be a moot point if we sum all the ranks. I'll tell you as to why. And naturally, T, the sum of all ranks, is simply T plus T minus. We're just summing all of them together. The test statistic cannot be the sum of all ranks. I'll tell you as to why it cannot be the sum of all ranks. Good. Erase the sign. So suppose we have n numbers, n natural numbers, whole numbers. The ranks that we assign are going to be natural numbers, not whole numbers, because we're going to get rid of 0. Natural numbers, no decimals, correct. So if I have n natural numbers, which would correspond to ranks, what would the sum of those n natural numbers be? To n. Well, if I sum n ones, it will sum to n, right? If I add 3 ones, I get 3. 4 ones, I get 4. My question is, what would you get if we did 1 plus 2 plus 3 all the way up to 15? In this case, n is 15. Sure, you can sit there and okay, yes, summation I equals 1 to n, great. But what would that reduce to? Do we know the formula? We went over this in time series.
I know we did. Look at Paul too, I was the only one there.
Wow. Oh, nice way to throw into the bubbles. N times n plus 1 over 2. So 15. 15 plus 1, 16. 16 divided by 8. 8 times 15, that's 80, 40, 120. So if you add all this, it better add to 120. Yes? So that would be the sum of all natural numbers. Now, why does this matter? Once I have the absolute value of the z, and I put them in order, and I have z1, z2, z3, z4. Yes, the absolute value when you assign the rounds based on the magnitude, you'd probably assign 1, 2, 4, 3. Yes. So no matter what you do, at the end of the day, you have to look at the sum of all the ranks. Do you agree? Yes. So n times n plus 1 over 2 will play a role, it has to play a role. Does that make sense? Because our test statistic is based on sum of all the runs with positive signs or sum of all the runs with negative signs. Good? Yes? Okay. Here is a question. Let's take the post minus pre case and blood sugar. There, the post blood sugar has to be less than the pre blood sugar. Do you agree? So if the drug is in fact negative, you have to see more of what signs compared to, well, more of which signs, positive or negative. You have to say more and more negative. So a reasonable test would be right tail or left tail. Has to be left tail, correct? Because we want to go below. So once you find the test statistic, that test statistic, sum of all the negatives must fall below the critical value. Do you agree? And likewise, if we go with a fuel injector case, post minus pre has to be more and more positive. The more positive signs you get, the better it is going to be. But once again, statistics, just because you have more positive signs doesn't mean it's effective, right? We have to be statistically right. We have to determine significance. So in that scenario, a test to perform would be a right tail test. Yes, so more and more to the right. So under the null, if there are no differences at all, we will have a distribution which is the Wilcoxon sign round distribution. If I sum all the rounds, it will end up in n times n plus 1 over 2. Correct? So T plus is simply n times n plus 1 over 2 minus T minus. Yes? Correct. So you're using that argument to sum all the rounds that would be n times n plus 1 over 2. So T plus would simply be n times n plus 2 over 2 minus T minus.
That's the T plus, so that'd be T.
So this is T. Sum of all the rounds. Right?
T minus U.
Huh?
What would the T minus?
Sum of all the negative rounds. Right? That would be sum of all the positive rounds. Positive signs, negative signs, total. Doesn't matter positive or negative. N times n plus 1 over 2. So how do we decide whether to reject or not? If we have a right tail test, we want to come up with a critical value. I believe your book calls it T sub alpha. If T plus is greater than T sub alpha, or greater than or equal to. In other words, the positive sign rank values exceed the critical value for the right tail test. It falls somewhere here. What should you do? Reject the null. Conclude that the location parameter is not 0 and it is more likely to be greater than 0. Just moving towards the right. For a left tail test, the critical value is going to be on the left-hand side. And if T minus, I'll call it, I think your book still calls it as T signals. Let's distinguish it. For the left tail, we'll put minus, right tail, we'll put plus. Critical value. If T minus falls below or less than or equal to P sub alpha minus, we would reject a null. Theta not equal to 0. And we find more evidence for theta less than 0. All we are saying is that there is an underlying parameter that is either going to shift to the right, shift to the left. We're not saying that underlying parameter is the median. We're not saying that the underlying parameter is the mean, right? It is just an underlying parameter. So we don't have a distribution at all. Mean has a distribution. The t-test for path differences, that test, the differences would follow a t-distribution. But here, theta, we're not assuming it to be mean, median, anything. It doesn't have a distribution, which is why we call non-parametric statistics as distribution-free or non-parametric tests as distribution-free tests. We don't have any underlying assumptions of distribution for the test statistic. Do we follow? Now, sadly though, the T alpha over here, I am distinguishing it. Have to go back and look at the text as to whether they put it as T alpha minus. Sadly, the actual critical value, if you want to find T alpha minus, there isn't a formula. We have to use R. So on an exam, I'll give you a table or so we can pick out from the table. I'll show you how to get that using R. So R has this standard notation. If you start a name with D, it means the density function. Last time we did D by norm, which gave us the PMF. If you start with a P, it will give you the cumulative probability. If you start with a Q, it will give you the quantile or percentile. Critical values are quantiles by default. So let's just take P sign rank. And you'll see it says P sign rank, Q, N, and lower tail. So N would be the sample size. So N could be 4, 5, whatever. Q is the quantile that you pick. Now, let's just say N is 5. Yes, if N is 5, the sum of all the ranks would be 15. Yes, so the maximum number that you can get is 15. So P sign rank 10, 15. By default, lower tail, sorry, it's 5, my bad. By default, the lower tail is true. In other words, it is going to give you the probability below 10. So I'll just leave it as is. Oh, couldn't spell sign rank. it gives me 0.78125. So 78.125% lies below 10. Does that make sense? Now, if I adjusted this and put it as 10.5, I get 0.84375. 11.2, I get 0.847375. 11.5, 90625, 0.90625. Here is a question. I sum all the ranks, natural numbers, I'm adding natural numbers. So why am I getting a real number? And why does it work for a real number? 10.5, 11.2, why does it work? Do you follow my question? If we have a bunch of ranks, in our case, 1 through 15, yes, those are the possible rank values that we can have. Because the maximum will be 15, sum of all ranks, for a sample size of 5. Why does it work for 11.5? Why does it work for 11.2? Where does the decimal even come from? Dividing it by 2.
So you see where there, is that where your other one?
No, this would always be E. Now, here's the thing. The first example, or the first few that I would do, I'll do without a tie. Now, sometimes the ranks could be tied, correct? If you have a tie, we want to break the tie. When we break the tie, we would end up introducing a decimal. So if 3 rounds are tied together, then we would sum the rounds and divide by 3. In which case, naturally, we will get a decimal value. Does that make sense? So even though the rounds, most cases, are natural numbers, if you have ties, we would end up getting a decimal value. If you change that to 15, I get 1. 25, I get 1. Why? Beyond a certain point, no matter what you have, cumulative probability will be 1. But it doesn't make sense for us to exceed 15 if the sample size is 5. Likewise, if it is 0, what should we expect to get? What? I get 0.03125. Huh? So 0. 1.0625. 2.0395, and so on. In terms of the critical value, we want the quantiles and not the probabilities. But I do know what 2 would correspond to. If 9.375% lies below 2, what percentile is 2? Okay, if 95% of the students took the SAT exam with you, and if a bunch of students took the exam with you, and 95% of them scored below you. So what percentile are you at? Huh? 5th? 95% are below. You're in the 95th percentile, right? 95% below. So in this case, 9.375% is below 2. So which percentile does 2 correspond to? On the left-hand side, the 9.375 percentile. In other words, if you approximated the 10th percentile, Yes, so let's see if it works. If our calculation is right, Q sine rank is going to give us the quartile, or excuse me, quantile. And once again, by default, lower tail is true. We always look at the probability below the quantile. I am going to pick a value of 0.1. 0.1 is 10%. Yes, and sample size, I've got to keep the same sample size, 5. I actually get 3, which makes sense, right? Because 2 is 9.375. Even if I go back and type 3, 3 is about 1.625. Because of rounding and stuff, there is a lot that goes in here. I'm not going to cover all that. You can look at the reference. It happens to be 3 for 0.1. So if you use an alpha of 0.1 and you are using a left tail test, the critical value on the left-hand side will be 3. What would the critical value on the right-hand side be? Point 0.1 above the critical value, so 0.9 below, I get 12. Yes? Yes, no, maybe. Now, using the same logic as n plus n times n plus 1 over 2 minus t minus, you can switch this around, right? If you don't calculate 15, the maximum rank that you get, minus 12 is 3. So if you find one of them, you can find the other. Yes? So same logic. Over here, t plus, t minus, that is the logic with the test statistics. We can extend it to the critical values also. I'll write it in a bit. Two-tailed test, we just have to divide alpha by 2. And when we divide alpha by 2, for example, on the right-hand side, it would be 9, 5, 14. On the left-hand side, it has to be 0, 5, 1. So if the test statistic falls above 14 or below 1, then we would reject. Otherwise, we will not. Does that make sense? Yes? Now, t plus t minus equal to the sum of all ranks would only happen under the null distribution, right? Under the null, that is true. In other words, no differences at all. If there are no differences, every single observation will be assigned a unique rank. So under the null distribution, you will get T to be sum of all ranks. Are we clear? So you need R to find the critical value. On an exam, I will provide you with a short, small table of critical values. So before we end, the critical value relationship that I mentioned, T alpha plus is simply n times n plus 1 over 2 minus T alpha minus. In our case, if that was 15, and you found that to be 3, 13 minus 3, 12. That's what we got. Switch it around, 15 minus 12 is 3. Does that make sense? So you find one, you get another, but as I mentioned, R can do both. You just have to determine what the area below is. Always when you enter, you are entering the area below. R does have the functionality to switch it around and do its area above. I don't want to confuse you guys. We'll just stick to what function we have. Yes?